Greetings, QCS build fans, and welcome to another episode of Let's Build a Server. I'll be your host, the Nerd Warrior himself, Ian. So anyways, we're going to build another server. If you couldn't tell by, well, the AsRock Crackboard and what are basically the usual suspects when we build a server lately. So, the biggest idea behind this one is customer was originally going to build this as a fax server for a medical clinic, because fax is still one of the most safest ways to transport medical records from one office to another for referral reasons. So that was primarily the main idea behind this. We figured that since if you're going to spend that kind of money on a server, on a multi-line fax server, you might as well add some hard drives to it and make it a backup NAS for the entire office. So that actually ends up what we're actually doing. And so because the software that they were going to migrate to just ended up being more costly than their current system, and the whole idea of moving to the new system was so that way they could save money, not spend more on, quote, what was a piecemeal hodgepodgey system that would probably be more confusing and harder to use than it was worth. So with that said, here we go. So kind of got the usual suspects. So we got our AsRock rack, EPYC 8D 2T board, which is our standard platform board that we use anymore. If you ever wonder why we don't use Rome, the Rome board, simply because of the fact that one, it's about $200 more, and also two, for a small business, you don't really need it unless you're doing heavy virtualization and you're using a lot of SSD, or you need a lot of super high-speed bandwidth on your PCI Express lanes. Otherwise, yeah, this works perfectly fine. So let's see, what else do we got? So we got our standard Noctua cooler that we always use, because this is going to go in a 4U rack mount case, just like all the other ones have been. We've got our SAS to SATA cable for our SAS headers on the board. We've got our Startech backplane for this, just like we always use. And of course, you're going to notice that there's a trend. We use the stuff that we know that works all the time and we have zero issues with. So hence the same reason we keep using the same Noctua cooler, we keep using the same backplane, we keep using the same motherboard. We're even using basically the same RAM. The only difference is this machine we're going to use 4 sticks of 8 gig for 32 gigs total of DDR3200 instead of the normal 64 gigs that we do, because we're not running a whole bunch of virtualization. We're not running a bunch of heavy applications or anything like on this. We're just basically going to run server, and that's it. So we got that guy. We got 2 terabyte drives. You notice they're the Barracuda drives, not the Exos drives. Main reason, these are half the price of the Exos drives. So again, this system is on a budget. So let's see. The other big thing you'll notice is that we're using the new Samsung 980 SSDs. They've gone away from the Evo marketing, and so now they're just the 980 SSDs. These are basically equivalent to these guys over here, which is the 970 Evo Plus drive. Pretty much the same thing, except I believe it uses a different memory controller. But other than that, it's almost identically the same unit. The other big difference we got on this one is you're going to see that our chip right here, it's in a blue carrier now. difference between blue and green is a Rome chip. This is a Naples chip. This is a first gen EPYC. This is a 7251 8-core Naples chip. Now you're probably wondering, why are you doing Naples instead of doing Rome? Because Rome has about a 20 to 30% performance boost over Naples. Well, the reason is Rome and Milan are extremely hard to get a hold of. So second and third gen EPYC parts are extremely tough to get a hold of right now, especially in the smaller core counts. Larger core counts, 24, 32, 48 core counts are fairly easy to get a hold of, but the smaller chips, the 8 cores, the 16 cores, the 12 cores, all those are very difficult to get a hold of right now. So, however, the Naples chips are available, and so they're not stupid expensive. So, I mean, this chip, I believe, was less than $600. So, you can't complain with that. Anyways, so we got that. Other big difference with this one is we're going to go to a fractal power supply. The only Antec that was available, and you know I'm a big Antec fan, but the only Antec that was available that I could get was the Signature Series 1300. That is massive overkill and way more expensive than what I wanted to use on this system. So we're going to use the Fractal Platinum Ion Plus 860p. So it's fully modular, pretty standard power supply for this. It should work perfectly fine. I don't believe we're going to have any issues. But it's also platinum, so it's not going to produce a whole lot of heat, even when this thing's under load. So the other beauty of this machine is later on down the road, we're going to be fully expandable. So if the client does decide later on that they want to get to virtualize their office or whatever they want to do, we can always drop in a new chip, because this board allows us 3 generations of Zen architecture on EPYC, and allows us up to, depending on the chip, up to 256 to, I believe, 512 gigs of RAM. So we got tons of expandability on this system. Now, one thing's missing. You're going to think, well, what case are we going to use? So we're going to see that here in a little bit when we get to the bench. But we're going to go ahead and we're going to use another RSV case for the in the Rosewill, like we did in the last server that we did. So if we go back and you look at the Rosewill EPYC server build, it's going to be a similar case to that. The difference is I believe that one was a 43 or a 4400. This one is the L4500, I believe. So the difference is it doesn't have the 3-bay 5 1/4 inch on the side, and it has the 3 fans across the front. So we're going to see if I like that one a little bit better than I liked the previous case. Other than that 1 bay choice on the one side, they're all identically the same. So, alrighty, let's get to the bench. Okay, so here we are at the bench. If you hear a little fan noise or anything like that, it's because the rig, the mining rig is running behind me. So hopefully you don't hear it too much. But, so here's the case. I've already taken the 4 side screws out of it, here, and on the front edge over here. So we're going to slide this back. Now if you go back to the other Rosewill EPYC server, you'll notice that this one's silver, and the other one was black. So, but this is what you get when you open it up. So the 2 big differences between the previous case and this case is, we'll show some pictures here of the front, is this one has a USB 3 port on the front of it, and we have 3 of the 3.5-inch drive cages, and I think these are, let's see, 1, 2, 3. I think these will hold 5 drives apiece. So, but otherwise, we got the same 120 millimeter fan rail right here. There's 320 millimeter fans up here. We'll show a picture of that, and then the 280 millimeters in the back. So, otherwise, and same support bar. Otherwise, everything else is pretty much the same. So, as the previous case. So, I'm gonna go ahead and take this support bar out here. Just to make our lives easier. And set that over here. So this is the goodie box. Comes on the inside. So in the previous one, we had carriers on this side that were black, and they were kind of like horseshoe-shaped trays that would hold your hard drives in place. This one doesn't do that. This one has these purple side rails that you screw onto your drives. This is very reminiscent of Antec Titan slide rails. So yeah, so that's our extra slide rails. There are, let's see, I always say that screws for, I say that's hard drive screws. And then this is all of our extra standoffs. And yeah, that's our extra standoffs and motherboard screws and everything. So, and the speaker, if you use such a thing. I never use it, so. Alright, let's put that there. Okay. Alright, so, but that's pretty much it for this, for the case. So we'll go ahead and I'm going to go ahead and take this guy out because I'm probably going to take these fans. Now these fans are set up so the Molex connectors are on the bottom. If you go back to the previous build, you'll notice I rotated them up. Also I changed them all up, most of them out. I changed out most of the fans with the Arctic P12s. I don't know if I'm going to do that this time. I think I might just leave them with the regular Molex full speed fans, as long as it's not too noisy. As long as I don't have to worry about the noise, I'll probably just leave the stock fans in here. So, but I'm going to rotate these up, so then that way this cable will actually sit up here, and then we can zip tie it to our cross brace, so then that way it allows for better cable management that way. So, alright, let's get this thing out of here. Alright, there's our big fan rail. So, alright. I'll leave those alone for the moment. I'm just going to set it to the side. Okay. Alright, go ahead and we'll get the motherboard in here and we'll start working on that. Okay, and as always, we're going to double check to make sure we're in the right alignment in our carrier. So 2 and 2 and 1 and 1. So right there. Okay. Alright, there's our chip. So 7251. Alright. So, as you can see, these are our new SSD 980s. Right, get our memory put in here. I always have to look it up and remember which one's which. Got our wide standoffs and our closer standoffs. So close, wide. So we're going like that, which is perfect because we won't have to readjust our fans. Because this will be our intake side, this will be our exhaust side, so it'll go out through the power supply. So ideal. Okay. Let's get started. Just like that. Alright, and we'll get our power supply. Okay, Velcro straps, just like in our Antec from last time. Our little bag here. Our little box of power in it. And there you go. And we have a switch for 0 RPM mode on and off. So when the power supply is not doing anything, you can just turn the fan off. We're actually going to leave that off like that. Okay, and you can see, now someone had brought this up previously, that, you know, the power supply actually pulls air in from the outside and blows it on the inside of the machine. It's actually incorrect. You can actually see that this fan actually, this is the front of the fan, this is the intake side, and they actually will exhaust out through the back. So, because other than the CPU and the GPU, the power supply creates the most heat. So it wouldn't make a whole lot of sense to exhaust it in through the inside of the machine. So That's our 24 pin. That's our, is that our APS 8 pin? I think that's our APS 8 pin. That's our PCI Express, which will be for down here. That's our SATA power. And that's our 4+4 CPU. So that's all the ones we're gonna need. And our front panel header. That's our USB 3. Power, hard drive, NIC 1, NIC 2. We'll actually run those underneath our drive pages like that. And keep everything tucked in nicely out of the way. We have our 8 pin. One thing I noticed about these particular power cables is they're very soft and flexible, which makes it nice for actually being able to move these things around, so they're not you're not fighting them like you do with some of them. Alright, so we're going to take the locking screws out. Unlocks it. Take this up. Now, the one drawback about this particular case that I don't really care for is the way these rails attach. They're just pressure locked in there, and so the issue with that is occasionally I already had this one installed and it wanted to fall out. So what I did is I took a small pair of pliers and I just bent the tabs in just a hair, so that way they grab onto the backplane just a little bit tighter. There. Now that won't come out. Okay, well that's it for the hard part. So we're gonna go ahead and we'll get the fans in here, we'll get everything cable managed, and we'll cut to the end here. Alright, well as you can see, we've got everything nice, neatly tied up here. We left all the Molex fans in. I really don't care for the quality of the Molex connectors on these, but of course it's Molex. Molex is like 30 years old at this point, and so yeah, they figured out how to make them as cheap as less than a penny possible, and they kind of suck at times. So but we got them all in. I've gone ahead and tested it, and the fans are all running and everything like they should be. So yep, we'll go ahead and get this thing loaded up with Windows, and then we'll get some screenshots for you so you can see what it looks like. Okay, so on here you can see this is a shot of the BIOS, and you can see that we've got version 2.6 for the BIOS. We've got our Naples chip installed, and it sees all of our RAM. You can notice it's clocked our 3200 megahertz RAM down to 2400 megahertz, and that's a limitation of Naples. Naples, I believe, has a limitation of 2666. And on this, try to hold the camera steady here while I do this. There is no, we can go into CPU configuration, but there's no adjustment for the memory clocking with this chip on this particular board. So, I mean, we have all of our PCI slot links that we can go through, and we can change everything in here, which is kind of cool because we can actually go in and change all of our slots to 4x4 or 8x8 if we want to. It only comes in really handy if you're running like a whole bunch of NVMEs, or if you're running a whole bunch of video cards for like mining or something, and you could go through and you could split the links on everything. And then you can see our storage. There's our drives already installed in there. So yeah, but no, we can't go in and change anything else. So one cool thing about this particular board is this is the hardware monitor. It's got a ton of sensors on that board for literally about everything. It's pretty crazy. So that's it. Alright, we're going to go ahead and load Windows, and we'll be right back. Okay, so just as a point of reference here real quick, so we got some drive statistics on these Samsung drives and the mechanical Seagate drives. So on the upper left, we have the SSD 980s, which we just put in the server. And then directly below that, we have the 970 Evo Plus drive on the Dark Fleet. And you can see that those two drives have about nearly identical performance. Then if you look at the upper right, you can see that is the RAID 5 set of mechanical drives on the server, and then directly below that you can see that is the 980 Pro SSD on the Dark Fleet, and that, of course, that is a NVMe PCIe Gen 4 drive, so it is a lot faster than all the others. So good little point of reference. But yeah, so the SSD 980 and the 970 Evo Plus are nearly identical performance between those two. And here you can see our finished install. So it's a vertical rack mount, just like we did with the black EPYC server build.
We'll reference that in the comments below, so you can go back and look at that build, which is very, very similar. And yeah, this thing's been running for about 2 weeks, at about the time that this goes up, and it's been working great without any issues. So questions, comments, concerns, please leave those in the comments below, and make sure you like, share, and subscribe to see more of this content. We've got sometime between in the next 18 months, we've got at least 3 more of these to do, and they're all going to be different. We got 1 or 2 are going to be in tower cases, so that'll be a little bit of a change. And then good possibility we're actually going to do a roam board on one, because it's going to be a super high speed database, medical database server. So yeah, so new and exciting stuff coming later on down the road, so make sure you like, share, and subscribe for that. So again, thanks for watching, and we'll talk to you later. Bye for now.